Alright, in this video I'm going to show the basics of series and parallel circuits, the difference between the two, how a circuit is formed, and then a sample calculation on how to calculate the current, the voltage, and the resistance of a circuit. The joke of the day says, when I was young I was afraid of the dark, but when I get my electric bill, now I'm afraid of the light. Let there be light. Okay, when looking at electric current, the current is the rate at which electrons flow. So let's say I have a small pipe or small wire and there's water flowing through it. Obviously a small pipe will have a small rate of electrons. If I have a much bigger pipe here, I'm obviously going to have a bigger current of water or a current of electrons. There are two basic types of electric current. One is called alternating or AC current. That changes directions. So if I'm looking at an electron, it's going to sway back and forth at a certain rate. The rate is based on the frequency of the electron flow. Typically it's 60 hertz. You also have direct current. In direct current, the charges only move in one direction. Think about a battery in this case. So electrons will only flow in one direction. That's why eventually batteries will run out of electricity. Looking at circuits, circuits is when you have a complete cycle of electrons flowing from one direction to another. You could either have them in series or in parallel. Here's a series circuit. You notice how the electrons are all flowing in just one direction. Well, if you look at a parallel circuit, in the parallel circuit there's little branches where it could go in multiple directions. Okay, again, for a series circuit, your current will only take one path for your electrons to flow. Think about the World Series in baseball. Let's say you hit a home run. You're typically going to run from first base to second to third to home. There's only one direction to go. Your current will flow through every part of the circuit. So it'll have to hit every base in order to get your home run, just like it'll hit all the resistors. In a series circuit, if you add a resistor, let's say you add another light bulb to a circuit, your total resistance will go up because the current must go through each resistor. The way to think about this with, say, aisles at HEB. So let's say you're going to HEB and you're trying to find the right lane to go in to get out of the grocery store as fast as possible. Let's say that you have to stop by one aisle, then you have to stop by another aisle, then you have to stop by another aisle. It's going to take a long time to get out of that store. In series circuits, your current will have to be the same. The reason for that is all the cars in a road, for instance, would have to go all in the same direction. All your electrons have to hit each individual resistance. So you could imagine cars being in cruise control. So you have a big path of cars traveling. Here's our physics car. They always look the same. Let's say it's going one direction. If you have another car right behind it, or say right in front of it, it's going to have to wait for that car to pass through the light, the green car, before the red car could go through. The current will be the same. They're not going to collide into one another. All right, in a series circuit, you got to add up all your resistors to get to your total resistance. Your total resistance will go up as you add resistors because all the current must go through each one. Let's say we have an example of a car. A car is going to have to wait through each individual light. It might have to wait at this red light first. When that light turns green, it'll have to wait at that light, and so on. As I add more lights, or if I add more resistance from slowing down the car, it's going to take longer for the car to get to where it wants to go. Okay, next, in a parallel circuit has to have at least one point where your current will divide. You have more than one path for your current to flow. That's why in most circuits you want to set them up in parallel, because let's say you flip a switch, you don't want it to light up everything at once necessarily. You might only want one thing to turn on. In a parallel resistor, if you add a resistor, the resistance actually goes down and not up. The way to imagine this, let's say we're at HEB again. Here is you. You have your little cart there. Yes, the cart looks just like a car. I know I'm not much of a drawer here. But let's say that you're trying to figure out what lane to go in. There's lane 1, here's lane 2, here's lane 3. As you add more and more lanes, there's more and more places where you could go with your cart in order to pay for the grocery bills. So when another lane checks out, you usually want to rush over to that lane because you could get out of the store quicker. In a parallel circuit, your current will flow into a branching point where it goes to more than one direction. Your same total current must flow out of the circuit as it came in. Your current will depend on your resistance in each branch. That's where you use the Ohms Law equation that we're about to go over to figure out your current. And here's a quick analogy of showing how fast electrons flow. Here I have a tollway. With a single resistor, all the cars are going to have to wait for that one toll to go through. If you have a series and multiple circuits, multiple tolls, you're going to have to do a long wait in order to get past the highway. But if you put them in parallel, again, there's going to be more paths for the electrons, or in this case, cars to flow, and that's what allows the cars to get through faster. Here's our main equation that you're going to use involving circuits. It's called Ohm's Law. It came from the scientists who developed the law. It details a relationship involving voltage, current, and resistance. Remember, voltage is essentially the amount of energy that a battery or circuit has. Your current has to do with the rate of how fast electrons flow. And your resistance is the tendency to slow down that rate. So our main equation is V equals I times R. Our voltage is equal to the current, or I, times the resistance. Here's a sample problem involving just one resistor. You want to sketch a circuit containing a 3-volt battery and a 450 ohm resistor. What's the current? Here's our 3-volt battery, 450 volt resistor. You notice how the current is always flowing in the same direction. That's our blue line. The voltage is going in the opposite direction, though, in this resistor. In order to solve for the current, you just do V equals I times R. Your voltage is 3. Your resistance is 450, and you'll divide the two to get your current. Now this is with a simple circuit. You're going to have some questions with more than one resistor, more than one, either in series or in parallel. You might have some even in combination, and those you have to still use Ohm's Law equation in each separate part.